My name is Mark Mann, and I want to share a class project that I've worked on as part of my MS in Applied Data Science at USC with my partner, Hanko Hwayne Johnson. It's a project that is using the Django web framework to enable keyword searches on a database. Give me any database, and we'll be able to search it with this app. So the goal is exactly that: enable multi-keyword searches. The customer can provide any relational database. It's very flexible, and we'll enable multiple word searches and ranking on top of that. And additionally, host it on AWS EC2 to enable access via the web and authenticate the requests just to ensure security. These are two of the example databases that we use and the relations within them. And what we're going to do is that we're using a Kickstarter database, mainly project, category, location, and alumni, kind of a mocked up alumni database of students, the lab they were in, and the work. Those are represented in MySQL tables, which we'll show later. But the goal of the app from inception is just to first just tell me which database do you want to search, and then a button for keyword search, and you input the search terms there. And then we'll take those, send the query out to the backend, which we're using, which is Google's Firebase, and then return the result to the user with rank results, and then enable some hyperlinked searches within that. So just to jump in, the data that is provided, it's this MySQL tables here. There are three different databases, each database with three tables. So our three databases were Kickstarter and Alumni and World. These are just kind of the examples of the data, the input. And after we run the input through our Python program, which can be set up to be recurring daily or weekly as the data changes, the result is that it's uploaded into Google Firebase. Each table is uploaded, but also an inverted index structure is created that shows the keyword and then where location wise it's appearing within each table. So this index here is created via our program, and it's enabling the search results. So this is an example Kickstarter database, and Firebase is cool because it's showing us the analytics as we go. So like downloads daily in real time, so you can really keep a pulse on that. Now to the actual app, this is it. Again, it's a proof of concept, so there's not much front end going on, but just given the database example, like Kickstarter, and then you give a search term, it's loading the results. So that's just a single word, but if I was to give multiple words here, we would get a ranked result. So here, single player was the query, and single player is appearing up above, and then below that we're getting results where single was just single or just player, like below that. And then we've also got we're using the requests, Python requests, so we pulling that request attribute to see the size. So this is also helping us understand like the payload each time. And as the data gets bigger, we'll understand like what needs to happen next to paginate if the result is too large. So yeah, we've got three different databases here. We play around with some different searches. Like associate in an alumni database is going to return folks who are an associate, or maybe they're a research associate. And then we're also just doing some simple error catching. So if the word is not there, it's going to return this result, but still search the word that there was a result for. All of this is enabled via the Django app, the Django web framework, which is a Python-based web framework, which has been very helpful doing this project. It's the model view controller kind of paradigm. So The actual web pages themselves, the core result here is found via a request out and then a result back. That's done via the views. So we have Python functions here just written to get the input from the user and then use that to send a request out and then reformat the results in the way that's needed for it to be rendered in the proper way. All the rendering here is done with just simple HTML pages. So it's a proof of concept, but we've got our HTML templates here. So these have been, my partner Hanka did an amazing job just getting these all straightened up. But the cool thing here is, as this HTML is enabling some hyperlinking. So if we each of the hyperlinks here are representing foreign IDs to another table. So if I click on a foreign ID here, we're getting the next result, and it's recursive. So it's this is the second page of linked results, but if there's another link, so we can kind of follow the rabbit hole, and yeah, it's kind of just like an expanding view of the data you've got there. So just to wrap up, we used Amazon Elastic Compute. This is kind of like a CPU in the cloud just to host the website. So this IP here is representing the Amazon EC2 instance, and we're running the app with the Django test server. So this website is only live when I am in EC2. However, one of the improvements we want to make is to add an Apache server so that's running consistently, just to handle the requests coming in consistently. So I'm not having to use EC2 all the time to have the server. And then, yeah, I think that's all I wanted to cover. I hope you guys enjoyed this video, and I'm open to any questions or comments, and thank you for your time.